Hi there. I'm Ant Newman. I'm Director of Content here at Spectro Cloud. I'm joined by two folks who really know what they're talking about for this topic. We've got Nolan Schultz, account exec, who is formerly an Army Special Forces vet. We've got Colton Shaw, principal architect. He's been working in the PubSec, the Department of War, for at least 6 years now. So we're here to talk about MOSA, the Modular Open Systems Approach. It's been around since 2019. There's been a flurry of memos out recently from the Department of War. Start us off with tell me, guys, what is MOSA all about, and why is it still relevant right now? Which of you want to take this first? Jump in.
Yeah, Nolan, I'll let you take that one.
Oh, okay. No, so MOSA is a modular open systems approach. Originally, it was set out for weapon systems, think aerial munitions, to allow flexibility between platforms and the actual munition itself. And then it's since been expanded over the last 5 or 6 years to include software-defined applications and software-defined systems within the military. So the best analogy I can give is like the Mali load carrying system in the military, where it's got weavable components and you can change portions of your kit around your surface area on your chest or back or rucksack or what have you. It's the same approach to software defined systems, having something that's swappable, composable, flexible. That way you can meet the needs of missions, regardless of whether it's at the strategic, operational, or tactical level.
Makes sense. Colton, what have you got to add?
Yeah, I think Moses is becoming really important lately now too, just because of the amount of software that we're building and then seeing how the software ends up being built and then the mission changes by the time it's designed. So we're kind of having to rethink how we design software now. And that's why this has been applied into software, not just hardware and physical devices anymore, because we have to rethink the mission's going to change so fast. We need to be able to swap out those components and modify it, because when procurement's done, as we all know, the mission need has changed or someone's already solved it a different way. And then we have to kind of rethink from the beginning.
That makes sense. I hate to bring AI in so early into the conversation, but a lot of the memos that the Department of War puts out are around competitiveness in AI and using AI for mission advantage. Is there an explicit link between MOSA and AI in the DoW strategy?
Yeah, I would argue very much so, because AI is one of the technologies to where if you look 6 months ago, it's different than it was 6 months prior to that. And then 6 months in the future, it's going to be entirely new. So if we're designing AI systems, platforms, drones, doesn't matter, for AI today, 6 months guaranteed for AI, there's going to be something new. I mean, we have CPU inferencing models coming now. So if we're designing based on the hardware we have available today, then we're not really keeping up with the mission, the pace, and how things move. And you can see that happen in Ukraine and other places too, where it's just you constantly have to churn and change because that mission need changes.
So we talked a lot about the swapping, the modularity, but we haven't talked so much about the open in the MOSA acronym. What's to stop me saying, well, I'm a defense prime and I've got a proprietary drone stack here, and I will give you updates to keep you on the cutting edge of AI. What's the openness part of this, and why does that matter just as much as the modularity?
Well, I think the openness is the flexibility part, right? I mean, our open source community is very powerful. There's a lot of great talent and IP and capability in the open source, and I think we'd be remiss to not leverage it. And I think the DOW and IC understand that. I mean, they're big open source users. It's baked into a lot of major programs. So I think the open part and the modular open systems approach is the ability to leverage best of breed, whether it be open source or whether it be proprietary, and marrying the pros and cons of that. Now, on one hand, you have, open source software, very powerful, but security is typically not inherent to those systems. It's capability. They're building cool projects. They're looking to meet an outcome. They're pet projects. And then you have on the DOW side and IC side require heavy security protocols, a very aggressive security stance, and right, it makes sense why they would be doing that. So I think what MOSA allows is that best of breed mentality of how can I take open source capability, how can I bring them in to a stack or to a system, and I can harden them and make them mission capabilities, and now I can tap into both sides of the fence. And I think really what I'm seeing, and Colton, I'd love your opinion on this, is you're seeing the transition from proprietary monolithic software companies that sell hardware to application. You're seeing that start to merge with this open source mentality, not because of this MOSA legal requirement, but because that it makes the most sense. You're starting to see these large companies that are leveraging open source projects or free projects in their stacks inherently. Then it just becomes a matter of who owns the SLA and who's owning, the engineering and the response times.
Yeah, I mean, to tag on to that, I think companies have started to realize that certain code bases can really specialize in something, right? You can have a really performant Postgres plugin. You can have a really performant file store. And those, why rebuild that when we can pull that into our platform that's receiving updates, being maintained? We can build that into our stack. And now as a company, I can specialize on my specific component of this larger mission system. So now instead of building this entire monolith application that involves me rebuilding all these components or kind of supporting all of these components, now they're kind of almost hot swappable to an extent components, and I can really specialize on my one. And then we're able to build it into this larger architecture. So we're seeing, because of MOSA and really this move to this modularity, we're seeing move to containers, move to Kubernetes, and really moving in this smaller form factor way of shipping software.
Yeah, makes sense. I mean, it's almost embodying the Unix philosophy of every component does one thing well, and you're not trying to build a Swiss Army knife here. You're building a scalpel. I guess in the Kubernetes world, we talk about stacks, and you've got your CNI and your CSI and your load balancer and your observability, and all of those best of breed components that you can choose from. And it's just taking that through to, well, it's now a software stack running on a drone rather than a cloud instance. What kind of experiences have we had of working within programs as they're trying to adopt MOSA? Like, have we seen any of those in the flesh, so to speak, whether it's during your service or in your time at Spectro Cloud?
Yeah, I've actually seen it a few times. So when I was a JTAC instructor, we were leveraging a lot of open source systems to deploy TAC servers, and this was 5-6 years ago. So we were just running Linux servers and deploying TAC, and using VPNs to log into the server. But yeah, I mean, we used a lot of open source stuff because it was free. And I think in small form factor, small unit applications, it makes a ton of sense. There's a lot of great open source software out there that if you're running a 20-man element, 30-man element, it makes sense. One, ease of use. Two, it's attritable. Three, cost. Right. But when you start looking at enterprise applications where you're supporting systems of systems, or you have a programmatic approach, that's where true open source, tends to falter a little bit. And I think that's where I've seen it in industry is it's like that illogical fallacy of they're taking a micro example and applying it to a system. And they say, well, I used this one thing over here. I want to use it now at the core level. It's like you're opening up a whole different can of worms when you're trying to apply it to a core versus a battalion or a company. And that's where I've seen the failover of open source. So small units, small form factor, it's awesome. I know there's a lot of great units doing a lot of great things using completely free software out there. But when you start to transition to an enterprise footprint, that's where the security implications become a lot more important. And then really those SLAs and support structures, the support in DIY is the why. So when you're undermanned and overtasked, then the support starts to fall and systems start to fail.
Yeah, I guess it's the pilot to production trap that we see repeating over and over again in every area of the private and public sector. And I guess the other element is the more layers you have in the stack, the more systems that effectively need to talk to each other, the more troubleshooting simple errors becomes a problem. Like which of these complex elements in this complex system created that problem in the first place?
Well, it's interesting with with a lot of the way that we're flashing drones with software is really from it's from a config file that's passed person to person. It makes sense. However, when you start looking at actual near peer fighting, and there's cyber implications, and you have different capabilities that are either enslaving or taking over these systems, or infiltrating, or I'm trying to think of the right word here, but basically degrading or impacting these software defined systems. If you don't have security control at scale, you're opening yourself up for a number of issues. And that's where I think at the small scale, it can start to impact the larger scale, where if you don't have a strong security posture, on the battlefield from a software sense, you're opening yourself up to a vulnerability, potentially from EW or cyber attack.
You bring in a really good point, which is that unlike in a data center or cloud scenario, where you're in a comfortable chair in a carpeted room and the connection is stable, a lot of the time here we're talking about in the field, in DDIL environments, at scale, like just the operating software full stop, regardless of the modularity and swapping of it, is a huge challenge. How are you finding the customers that you work with addressing those challenges? What do you think are some of the best practices to follow?
Well, I mean, I think there's several different scenarios. So some of the conversations I've had recently are looking for, same way we do with air-to-ground attack, right? You have an off-board host that has ammunition but doesn't have line of sight of the enemy. You have a unit that doesn't have ammunition but has line of sight of the enemy or has the enemy location. How do you federate the two? How do you launch a system from one unit and then the other unit does terminal guidance, right? We do that with aircraft all the time. Now, how do we do it with ground-based drone systems? And that's just one scenario. The other scenario is looking at, some of the things that they're running into in Ukraine, where these highly specialized drones are really good at what they do, right? You mentioned Unix, one system does one thing really well. Well, there comes a time, on the battlefield where sometimes you have to use a spoon as a knife. How effectively can I do that? And I think that's where the swappability and composability of the software for the drones becomes very important. And I'm not talking about like, hey, you're in a gunfight and you're reprogramming a drone, but I'm saying you're in a prolonged campaign and you're in a more permissive environment, like a combat outpost, or you're in a mission support site and you have a minute to actually refit your gear. That's when I'm going to look and say, hey, I have drones that are doing A, but I need them to do B. How can I switch the software? How can I switch the capability? How can I switch the payload quickly and on the fly? It's no different than some of the actual weapon systems that we carried. I'm thinking SCAR heavies, SCAR lights, M4s. Like there's different modularity setups that we have that we can turn an M4 from running an EOTech to running an LCAN or running a Night Force scope and extend that range from 300 to 700 if I have to.
Colton, what's your perspective on this as an architect when it comes to doing large scale software swapping out in the field? Like, for example, with our platforms, how are we helping customers with that?
Yeah, I think for what Nolan's effectively saying is it needs to be almost dummy proof. Anyone's able to swap it out easily and really follow a few instructions, not a large SOP. So what we see in the field, I mean, especially for how we load drones and stuff, is right. You're booting from a USB drive, you plug it in, you're installing the software, and that's done, or some plug and play, right? So the ability, because oftentimes you don't have the time to think about what's wrong, what's broken. We had this when we were supporting an exercise in Australia, right? They didn't have the time to really dig in and debug. They needed something up and running. So the ability to go in and rip out a software, guide someone via like a webcam or something, quick rip out this software, put in this, it's going to solve your problem, or it's going to be tested enough to get you to the mission outcome you're looking for. And then we can move on and solve it on the back end if we need and build a larger system. But the goal is to keep the mission moving in that time. So it becomes kind of difficult when you don't plan ahead for it. When you design your systems to do one thing only, it's difficult, if not impossible, to hot swap based on mission needs. But if we're designing from the beginning and saying, well, this is the outcome I want, all these little pieces under here are just components of my outcome, and I can swap them out as needed, then it becomes a lot easier to do. So as an example for different AI models, the ability to swap those out. Here's a new model, here's it loaded on a flash drive, or you can pull it from here, however you get it to that device. Here's a new model, swap it out. Here's 2 steps to do it. Now it's a whole different machine. It's able to do entirely different outcomes based on that, or even just the inferencing layer or collaboration layer, right? Whatever you want to throw on it, being able to easily swap those out.
Sounds good. It sounds like the sort of the optionality of how you make the changes, how you deploy the devices, it matters as well. Whether it's pulling from a repo or sneakernet. You kind of suggested there, I think, an important recommendation about how project leads should be designing for the future, because you don't know what the future is going to hold. I guess I'd ask you to look into your crystal ball a bit. We've had this MOSA since 2019. It's 7 years in. Where do you think we're going to be in 5 years' time? What's the adoption going to be? What changes are we going to see in the way services are procuring or designing systems?
Honestly, I really think we're going to have to start having our own crystal ball and looking ahead for all of that and understanding the mission need I have today is one need. We've got to solve that. But how can I solve this mission need for the one that I can't see yet, right? How can I keep my options open when I'm purchasing, when I'm designing software? So I know that if I need this outcome in the future, I don't know what's coming, but we can swap this out and still reuse this without deprecating this entirely and going through a whole new cycle of procurement and designing that software. So realistically, I think keeping our options open are going to be the most important part, especially as we see AI kind of take over everything. You want to throw AI onto every device. If we start shipping tens of thousands of units of hardware with AI capabilities today, they're going to be obsolete by December. So we're going to have to redo all that again, unless we're planning that in advance. What is that hardware? How can I swap it out? How can I add on to it? Or what am I pulling to make that extend its life?
Well, Colton, I think the thread that you're pulling there is velocity, right? And I think, if you look back the last 100 years or really, 100 years of warfare, I mean, that takes us back to World War I, where the tank came on the battlefield. And then by World War II, the horse was obsolete. Well, now things are progressively getting faster and accelerating in velocity to where something you feel today is out of date a year from now. And then now we're on the precipice of tanks redefining their mission, because tanks might become irrelevant because I can take out a multi-million-dollar tank with a $500 drone and a shape charge. So, war is increasingly changing and it's becoming increasingly software defined. And I think that's really the crystal ball, is say, I need to start planning under the assumption that what I build today will be irrelevant in a year. And I need to have that in my pace plan of how I'm architecting these systems, because I don't have time to build a 3 to 5 year program of record. And I mean, I experienced this downrange. I'm not going to name the program, but I get fielded equipment that's already obsolete and I can buy better stuff off the local economy. So that was 10 years ago. What it looks like today is we're building these systems as systems and they're going to be obsolete in a year. So in order to future proof, that needs to be the mentality of how can I build something that I can change, that's composable and flexible, that I can keep relevant in the out years.
Yeah, you see how Ukraine has innovated an entire drone warfare ecosystem that 5 years ago no one was speculating about, and they're using guys leaning out the back of trainer planes with shotguns to shoot down drones and all kinds of quick responses to changing battlefield dynamics.
So I mean, we saw drones on the battlefield. I think 9 years ago is when they first started showing up, and they were dropping small form factor 40 millimeter grenades on weapons depots and stuff. I believe that happened in Syria. So I mean, we were seeing that when I was in Afghanistan. I experienced drones, but it was nothing to the scale. I mean, Ukraine has completely revolutionized how we look at Suez drones, using FPV drones for attack. I mean, we've had weapon systems like I think it's called the Sling Blade. I used to shoot it out of a mortar tube, and it was a manned drone that you could fly. I mean, that's probably 15-year-old technology, but I think how they mass the drones and how they can do it at scale is really what's changing the battlefield. And there's going to there's always a reaction, right, to battlefield capability, and I think there will be a counter drone technology. Russia's already starting to experience or experiment with some that are quite effective for the fixed wing long loiter time drones. It will be in the next couple of years where we've developed an effective CUAS capability for Suez drones or FPV drones. However, then there's going to be a reaction and we create other drones. And that ties back to that software defined warfare. You said something earlier, warfare is software, it's becoming software. Everything that touches the battlefield has software in it now. So, how can you keep up with the pace of change when you're in that, finite or infinite turn-based game?
And it's a lot quicker to iterate code than it is to produce new hardware and ship it to the field. So
Exactly.
we've talked a lot about the program owners and open source technologies. We haven't talked a great deal about the role of vendors in this. And in one sense, the whole idea of MOSA was pushing back against some of the large defense vendors and their proprietary systems, which were meant to keep them on the gravy train for decades. What kind of advice would you give to program owners about how they should treat their vendors in this new age and help them support MOSA? What would you say to they should do on their next vendor meeting they go into?
That's a really good question. I've been asked these questions before, and I think they're great, right? I think PMs should be asking, what does your software not do that this other software does or my current capability does? Because every vendor is going to tell you how great their software is, but ask them the actual gap questions and hold them accountable to it. And if they can't answer that honestly or articulate it, then that should be a red flag. I think the second piece that you should be asking is what happens inevitably when this contract ends. Let's say you come in and you set up this field of dreams and rocks are levitating and everybody's happy. Well, what happens when the contract ends? Because inevitably companies change over time. Their pricing strategies change. Their costs go up because of inflation, but also corporate bloat. So what is your strategy as a consumer to break up with the vendor? And again, that ties all the way back into future proofing. What is my strategy when my software is obsolete? How can I increase the capability in a modular sense? And then the same token goes to, yes, I brought in this magical software that's amazing today. Well, what happens in 3 years when there's a more amazing or better software, or this company is no longer, a good partner?
Sounds good. Colton, what advice would you give to your customers about how to challenge their vendors?
Honestly, I don't know that I add much more than what Nolan said. How do I break up with you is the number one question to ask our vendors, because like Nolan said, at some point it's going to be irrelevant or gone. So how do we design these new platforms? How do we continue to move forward? And that's really where a lot of this MOSA comes into play, because if I build with that in mind, I can swap out these components. And remember, I'm swapping out a specialized component for another specialized component, but the whole base infrastructure, the data that we've acquired, everything we've designed theoretically is still relevant if we're able to make that one distinction.
Fantastic. Gentlemen, this has been a fantastic discussion. MOSA sounds like it's more relevant than ever, and looking ahead, whether we've got crystal balls or not, still going to be a big part of warfare in the future. Thank you so much for your time. Thanks for those of you watching. Have a good one.